With the surveying terrain module, you'd want to go and do platform designs, terrace volumes with cut and fill. I'm going to show you more of this. Before we do so, I'm going to take full advantage of the render view to show you what the site looks like. Civil Designer also gives you the option of using some preset terrain settings. To show you an example, if you want animated contours, you can increase or decrease the contour density, which will assist with determining your catchment areas. Reverting back to what we had before, and then exiting the render view. Now that we know what site looks like, I'm going to go and turn off the bitmap or aerial photograph, turn on the cadastral. And when we do our platform designs, I want to be able to see beneath the ground. So I'm going to turn on the shade transparency. Zooming into the design area of choice. Looking at platform or terrace designs, there's different ways that you can do it. For demonstration purposes, I'm going to show you how the strings functionality works. I'm going to start off by going to strings, string creation, define string graphically. There's different options available to you to define the heights for the bend points. In this case, I'm familiar with the site elevation, so I'm going to put that all in at one elevation. And then click along the intended route. Because of its user-friendly functionality, it's very easy to draw this in, very much like you would drawing CAD lines. I do have the option to right-click and close. Alternatively, I can leave it open, and at a later stage, I could go and select it and then change the properties of that string. I can move the string as a family, or I could move individual vertices. This is what we refer to as a parent or master string. From the parent, you generate the child, and the idea behind that is if you do go and make changes to the parent, the child would dynamically update. Then go and put in the embankments using the child string. So we go back to strings, string creation. I do have the option to apply a curb if I'm doing a parking lot design. Let's do this before we put in the child. So we go to apply curb, put in a full range on the outside of the master string. Civil Designer comes with a library of curbs to choose from. You would select load group, specify which curb you'd like to use. We've got the Vanstone, the SABS, the British standards. You can also customize your own curbs. Now that we've got the curb, let's go back to putting in the embankment. We go to strings, string creation, create child, select in full range. When we create this child, you can go and customize the name, operation types, and there's many to choose from. In this case, I'm going to go and grade it to the ground level. Specify cut and fill slope, and they can be different. Those additional lines that we see, those are the dynamic contours that have already been drawn for us, and the selected line is the toe line. If I take the parent and I move it, the child would dynamically update. Next up in your design process, you probably want to give the parent string a bit of grade to make provision for stormwater drainage. You could right-click, select string operations, string long section, and make changes to your design using the toolbars on the left. You could, for instance, take a vertex and move it up and down, and then ask Civil Designer to interpolate elevations in between two vertices. In this case, I'm going to do the change via the plan view. So I go to strings, range editing, vertical grade. Specify a start point and an end point. specify which side I'd like to edit, and I choose a negative 2% grade. The contours are dynamically updated. If I want to edit the other side as well, go back to strings, range editing, vertical taper, specify a start point again, end point, select the other side. For verification purposes, again, you could right click and select render view and go and view this from a different perspective. You can see what is in fill, and then looking beneath the ground, you'd be able to see what is in cut. If I do zoom into the parent string, you get a better idea of the curb that we inserted. With cut and fill volumes, you go to strings, string editing, and you select volume. Specify the parent string. If you do have additional surface information that would include extra over, let's say for your hard and intermediate material, then you could go and include those in your volumes straight away. You'd simply go and specify which surface to use. And that would be included in the cut and fill volume. Straight away, you could go and specify the topsoil to strip and compaction factor. And for reference purposes, you could go and customize your description for your volume calculation. This is reference to a report volume that I'll show you. Specify where you want to see the results. The screen output would be here on the right-hand side. If you want to send the results to a printer or create a text file of it, or the option of all three. Looking at the output bar, we've got the volumes, which also then includes your curb quantities. In an ideal situation, you want your cut and fill volumes to be optimized. In that case, you go back to strings, string editing, select balance cut and fill volume, and then switch off the extra over option. And I'm opting here for 5% optimization difference between my cut and fill. If I want to update the description, it will take the parent string, it will alter the elevation, calculate the cut and fill volumes until it's within the 5%. If I now go to terrain and I select report quantities, there's the previously mentioned curb quantities, and then looking at the two calculations that we did, one where we didn't specify the optimization, and then the second one, or the phase 2, with the optimization turned on. Still staying with strings, I'm then putting a new string on top of this existing string. Before doing so, I'm going to update my display settings. I'm going to turn on the banks. And I'm going to turn on a CAD layer that I'll convert into a string. Changing my pen colors so we can distinguish the difference in the rendering. This is a lightweight polyline that I've gone and selected. We don't convert that into the string, so we go to string creation, string from polyline, select polyline. You do have the option to specify the heights from the polyline. In that case, with the 4 different vertices, they would pick up the elevations from those vertices. In this case, I'm going to do things a bit differently. I'm going to ask Civil Designer to go and add a constant of 10 meters to not only the ground surface, but also the existing string that we've already created. Earlier on, I mentioned you can create embankments for partial segments of the string. And then select the new string. I'll go back to string, string creation, create child, partial range. Specify on which side of the new master you want these embankments to be. Select a start point and an end point. I'm happy with the range. Customize the default settings and then include the existing string when we grade this. Pressing escape and then hitting spacebar to bring up the previous function. Select the master, select which side I want, the start point and the end point. Let's take a look at this in 3D. Right click, render view, and then zooming in and viewing it from different perspectives. If you're looking at dam volume design, I'm going to show you another example using the survey and terrain functionality. Now open up a different project. To give you an idea of what the site looks like, again, I'm going to render the view. And then using the toolbar here on the right-hand side, we get a better idea as to what our site looks like. We've gone and put in this dam wall, and the idea is to calculate the dam volume behind this wall, and then also look at our flood levels. Looking at the dam volume, we go to terrain, scroll down to dam volume, specify the water level and which surfaces you're working with. If you choose to select a reservoir file, you could use it inside the stormwater module to simulate retention or retention ponds. Reading my prompt, I click inside the dam, specify where you want the result, and looking at the cumulative volume in that case, close to 226,000 cubes. You have the option to export this as a CSV file. And looking at the graph, you could go and specify what needs to be shown. Civil Designer has left a polyline indicating the water level that we specified. Using the strings functionality that I've just shown you, we're going to convert that polyline into the string so we could view it in a 3D format. And then pick up the elevations from that polyline and then rendering it. Not only have we calculated the dam volumes, but we can see it in a 3D format. Looking at flood levels, I'm going to delete the dam for presentation purposes. I'm going to go to terrain, drainage, and this time select flood levels. Specifying the flood level. I'm then going to put in a solid fill at the flood level only. Don't forget that you have the option of putting in a description for later reference. And then looking at the updated cumulative volume. Again, if you want to see that in 3D, you could go and render the view. Another function that I'd like to show you before we leave the surveying terrain module is looking at surface maximum. Once I go and select this icon, the flood level will change. it will use the highest elevation within our site and then calculate the volume from the highest elevation, which would essentially be a fill volume. It may be for borrow pits that you'd like to use this functionality. Again, you could go and specify which CAD output you'd like to use and make things interesting. I'm then going to put in a polyline at every depth increment. Looking at the new cumulative volume. If you go and render that now, perhaps easier to understand what the function does when I show it to you in the 3D rendering. Taking the highest point, projecting that along the perimeter of your site, and then calculating the volume. That's the surveying terrain module.